po Eric Angat, your teacher in Earth and Environmental Science. Today, our essential question is, how is combustion compared to nuclear reactions? Our lesson yesterday, as a review, was about the importance of the sun to Earth and of course to us. The sun is the one that powers photosynthesis. Without the sun, then photosynthesis will not happen because the energy of the sun is the one used by the plants in order to react carbon dioxide with water and produce glucose and oxygen. Glucose is the food that is given to us by plants, which can be converted in different macromolecules. And oxygen is the one that we breathe. So, ultimately, without the energy from the sun, the process of photosynthesis will not happen, and if we lose the sun, then we will starve to death. Not only that, we will not also breathe because there will be no oxygen. The food that we eat comes directly or indirectly from plants, and the air that we breathe comes from plants too. So plants are the one that allows us to survive, and what allows the plants to survive is sunlight. Another benefit that we get from sunlight is that our skin is enabled to produce vitamin D that allows our bones to be strong. So the sun is really important to us. It provides us light, heat, and energy. But what powers the sun? The sun is powered by a nuclear reaction called nuclear fusion. In nuclear fusion, small atoms combine to produce a lot of energy. In the case of the sun, it's sunlight and a bigger atom. Two hydrogen atoms fuse together to produce sunlight. Now, if you will look at the screen, this is our essential question. How is combustion compared to nuclear reactions? There are two types of nuclear reactions, fusion and fission. We'll be dealing with the assessment probe later. Now, with nuclear reactions, it all begins with the atom. And this figure here is very familiar when you watch the cartoon Jimmy Neutron, right? Now, this is the atom right here. The center of the atom contains most of the mass of the atom, and it's called the nucleus. And the one revolving around the nucleus are called the electrons. So this is the atom. And there are more than 100 atoms, and we can see them in the periodic table of elements. Now, these are the two types of nuclear reactions. Again, we have nuclear fission and we have nuclear fusion. The main difference between the two is that in nuclear fission, the atom separates. While in nuclear fusion, atoms combine. This here is the one that powers the sun, and this here produces more energy than this. So nuclear fusion produce more energy. That is why the sun produces a lot of energy. Again, what powers the sun is nuclear fusion. Now, this is nuclear fusion right here. In nuclear fusion, two or more small atoms collide or fuse or combine at high speeds and become one. The process produces a lot of energy, and that energy is usually light and heat. Again, in the case of the sun, It's sunlight. I am reiterating that what powers our sun is nuclear fusion. Now, this is our sun right here. The sun is able to produce and release energy by means of nuclear fusion. And this is how the process happens. Two atoms combine, producing helium and releasing a lot of energy. Smaller atoms fuse, a bigger atom forms, and a lot of sunlight, light and heat or energy is produced. This is nuclear fusion. The process should happen at a tremendous heat and pressure, and the atom should be moving at a very high speed for nuclear fusion to happen. Now, sunlight can reach Earth because sunlight can travel in the form of radiation. And in our previous discussions, we said that radiation is a type of heat transfer that does not need a solid, it does not need a gas, it does not need a liquid. It can travel in the absence of this different kinds of matter. So it can reach us through the form of radiation. Now, this is now nuclear fission. Nuclear fission is not totally similar with nuclear fusion. In nuclear fission, the nuclei of a large atom splits. The splitting of the atom releases large amounts of energy, but this energy is smaller compared to the energy produced by nuclear fusion, but still very much energy. So this is nuclear fission. Again, it is the splitting of the nuclei of the atom. Now, nuclear fission is the one that is used in nuclear power plants. Just like this one. This is a nuclear power plant. And we have a lot of nuclear power plants in North Carolina. We have less on the west part of the United States. We have more in the eastern part of the United States. The steam makes the turbine spin while the generator produces electricity. So the heat produced in nuclear fission turn water into heat, and then this heat is used to turn water into steam. And again, that steam is used to oscillate the turbine, and that mechanical energy is converted by the generator to produce electricity. That is why we produce a lot of electricity in our nuclear power plants here in North Carolina. The main fuel of a nuclear power plant is uranium. Okay? Now, this is a nuclear power plant. Now, nuclear power plants are said to be environment friendly. Why? Because they do not produce carbon dioxide. The somewhat smoke that you see coming out of the nuclear power plant is not carbon dioxide. That is steam. So, these nuclear power plants do not contribute to global warming. They do not pollute the environment. But the main problem about nuclear power plants is that if there's a meltdown, then the whole place, about 90-mile radius, will not be habitable for thousands of years because of the radiation. But if it's working properly and no accidents happen, it is very good for the environment because it can produce a lot of energy while not producing a lot of pollution. Okay? You might be asking, Mr. Angat, why do they use nuclear fission in nuclear power plants and not nuclear fusion? It's because nuclear fusion as of now is not yet controllable We cannot control it. And we don't have the ability to create enough pressure and heat to make it happen. In one of the movies of Spider-Man, Dr. Octopus, a bright man, a scientist, wanted to help the planet move away from fossil fuel because fossil fuels like coal, oil, and natural gas are destroying our environment. So he created this mini sun. His goal was very good. He created that mini sun so that it would provide power to the planet, clean power, using nuclear fusion. However, Spider-Man and the other scientists learned that it was not safe to use it. He cannot really control it. He tried his best, but he can't just control it. So at the end, he realized this, and I don't know if he lost his life there, but then we have to remember his goal was good, but then the repercussions of what he created were like really, really dangerous. Okay? We do not have the technology yet to control nuclear fusion. But in the future, if we will have that, then we will have less nuclear power plants. Because nuclear fusion produces more energy than nuclear fission. That's just how it works. Now, nuclear power plants still use nuclear fission because nuclear fusion is still uncontrollable. Thus, it is only used for mass destruction like bombs. We can only use nuclear fusion in creating bombs. And they are very strong bombs. If a bomb is working because of nuclear fusion, then it would obliterate a lot of places and lives. Now, this is the map of the nuclear plants in the United States. You will notice here that they're almost all here on the eastern part of the continental United States and only a few on the western side. Can anyone tell me why they built so many nuclear power plants on the eastern side? Yes?
Is it because uranium is most probably found there?
Maybe, but uranium can be found in like many places, not just in the eastern part of the United States. So, look at all of these nuclear power plants. Any other? Yes?
Is it because there's more people that live up there, so they need more energy?
Even if there are only 10 people here, then it would not be fair if you put them all here. Any other idea? Now take note. Here on the west, number 1, this is the side where we have the Pacific Ring of Fire. The Pacific Ring of Fire is the place where what happens? A lot of earthquakes. And not only that, this is also where the San Andreas Fault is located. So this place here experiences a lot of earthquakes because of the active tectonic plates. While on this side, we don't have so much active tectonic plates, so they built them on this side because it's safer. Does it make sense?
Yeah.
Okay. Again, this side here of the United States is along the Pacific Ring of Fire, and the Pacific Ring of Fire is where most of the earthquakes happen. And added to that is that the San Andreas Fault is also located there. And Mount St. Helens, of course. Not here. We only have a few fault lines here. That's why we seldom experience earthquake in North Carolina. Okay? It's very uncommon to us. So they build them there. Now, how about combustion? Combustion is not the same with nuclear reaction because in combustion, you need oxygen. You cannot perform combustion unless you have oxygen. The CH here refers to the hydrocarbons which represents the fossil fuel like coal, oil, and natural gas. Coal is the most polluting fossil fuel, while natural gas is the least polluting fossil fuel. All of them need oxygen so that they can burn and produce heat that can be used to produce electricity like in coal power plants. In the process, they produce a lot of carbon dioxide that causes global warming. They also produce water. Of course, the water is because of the combination of those two. Combustion is not the same as nuclear fusion. Combustion requires oxygen. Nuclear fusion does not require oxygen. Okay? But we are so dependent on combustion because our cars, most of them still run using fossil fuel. That's gasoline and diesel. Okay? Most of our electricity production comes from fossil fuel still. So, I hope with these ideas, we have answered the question about how is combustion compared to nuclear reactions. Thank you so much.